Yeah, welcome everybody today. I'll get it started today. I'm going to give a little bit of background about QIF, kind of high-level background about what is QIF. So, my name is Daniel Campbell. I'm the Vice President of Model-Based Definition at Capvidia. Capvidia is a software technology provider in the model-based definition space, and especially in the QIF area, we're very involved. I'm the chair of the QIF working group. We're currently working on the launch of QIF 4.0. Right now we're on QIF 3.0. And I'm a member of the board of directors of the DMSC. So we have a little bit about the DMSC. I'll skip over that. Curtis kind of just gave a very nice background there. I would like to highlight just some of the members, our current membership in the DMSC. As you can see, we have a wide range of members from technology providers, software technology providers, hardware technology providers, end users, academia. This membership is growing constantly. These are kind of the leaders in the space of quality standards and MBD and so forth. The board of directors. So Curtis, who was just here, is the president of the board of directors. And we have representation: Sam Gambrell from Lockheed, Jennifer Herron, Action Engineering, Jeremy Hamilton, John Deere, Hermit Vega, Pratt & Whitney, Rosemary, who was just here. It says Purdue, but actually she is with NIST. And then myself with Capvidia. And then the final sort of statement I wanted to make about the DMSC is that if you're not a member, if your company is not a member, you should become a member. If you're here at this organization, or if you're here at this conference, you're clearly interested in this area, and so if you want to have your influence on this important standard, you should become a member. You'll influence the standard, and you get to network with some of the leading thinkers in this space. So it's a very good opportunity. I'd encourage you to talk with Mark about joining. So let me get a little bit into QIF, and I'm going to give a little bit of an overview here of what QIF is about. And I think, obviously, we've heard a lot about QIF over the past couple days, but this is kind of a little bit of a summary. So some of this might be not new to some of you, but hopefully we wanted to give a sort of a high-level summary of what is QIF so people get a cohesive view of what our vision is for implementing QIF. So we've kind of thought of these four major ways to describe what some of the value of QIF is, what we were trying to do. So first of all, I mean, it's let's call it a data library. I mean, it's we at the DMSC had many years worth of experience in the structure of quality data, especially, and how already being the maintainers of the DMSC standard, which some of you may or may not be familiar with, there was a lot of experience in terms of data capture on the metrology side, on the quality side. And so with that experience, we were able to build a very rich semantic library of how an enterprise needs to capture that quality data. And so that's sort of one of the major facets of what QIF really is. We built it using XML technology, which was a little bit of a no-brainer, but it's nice because it means that it's very easy to implement. And so it's not only sort of professional software companies like Capvidia that implement QIF software, but it's also end users that will implement software that's able to read and write QIF, maybe in a more basic way, with Python scripts and XPath or something like that, but something really simple to just be able to go into QIF data and query the data. I mean, it's your data, so you should be able to query it as easily as possible. And that was our vision on choosing XML and the approach that we took there. Another important aspect of the standard is how it's linked to the model-based definition. I mean, so this is in a way, I think, what one of the core innovations of QIF is that there was already a lot of expertise, like I mentioned, on the quality side and understanding the capture of quality data. In other words, that is capturing the data that's that characterizes the parts that are actually coming off of your production line. And we were able to, establish this rich data format that can link that data back to your nominal product definition, which resides back in your PLM system. And that's kind of one of the key sort of innovations of QIF, is providing that link between the engineering side of the world and the quality side of the world. And then, very importantly, it's a standard. This is not a proprietary data format. It's an ISO standard. It's which means anyone can implement it. It means that if you invest in using QIF data throughout your enterprise and you don't like the software vendor that you've chosen, well, you could leave that software vendor and do whatever you want, and do a completely new implementation, and you don't have to worry about losing your data. So that's another very important aspect of the intent behind QIF. So now that's kind of a high-level explainer of what QIF, of what the intention is. I want to go into the key, the key technical core of what's behind QIF, and that is the idea of features and characteristics. I mean, if there's one thing that I want everybody to be able to leave here today with, is this understanding of why features and characteristics are so important and why they're kind of at the heart of of how QIF is designed. So what do we mean by features and characteristics? So features, we could say that a feature is basically some type of an abstraction that wraps some portion of your part. I mean, that's we could probably go on having a philosophical discussion about what a feature is, but for now, I think that basically captures the idea. The name feature can be a little confusing, because if you are inside of, if you are a CAD user, feature might mean one thing to you, but in this context, feature might mean another thing. If you're in the simulation world, feature will mean another thing. So it means different things based on different contexts. And in this context, what we're talking about is maybe we call it a tolerance feature, or a metrology feature, or a measurement feature. But really what we're capturing is the region of the part that's being controlled by the given characteristic. And so what do we mean by characteristic? So these more, if we're talking about MBD, or the MBD use case, loosely speaking, what a characteristic is that corresponds to an annotation that you have on your part. You're putting an annotation on your part, and that is some type of a control or some piece of metadata that's being applied to that region of the part, to that feature on your part. Maybe that's a geometric tolerance, like a position tolerance. Maybe it's a dimension tolerance, a size, or a distance between a couple surfaces. Maybe it's some kind of a specification, captured in a note. Maybe it's a weld, a weld call out. Maybe it's a surface finish, et cetera, et cetera. And so the idea is you'll have these characteristics, and they will reference features, and then your feature will reference your product definition, which in an MBD world hopefully will be your CAD model. So that's kind of the key sort of technological foundation of how QIF works. Here's the sort of wheel, the lifesaver diagram that you all have probably seen quite a bit so far this week. But these are the application areas of QIF. And so this is, these are sort of the different data segments of QIF that enable different types of operations. Now, when I say application areas, I do want to be clear about one thing. It's easy to look at QIF and to look at this and think that, or forget that QIF is a data format. QIF doesn't do anything. So, sometimes you'll think people will be talking about, well, I'm going to use QIF and I'm going to do this. Well, QIF doesn't do anything. You're going to have software that does X, Y, and Z, and it uses QIF as maybe an internal data representation and a sort of storage data representation. But so what we're talking about is the format in which we can store data that supports these different areas. So what do we have? We have QIF MBD. This is sort of usually the core of, obviously, MBD-based workflows using QIF. What we're talking about here is the CAD geometry and the 3D PMI. It's pretty rich. It can support the full range of all the PMI coming from the major CAD systems. And that, of course, includes things related to quality, like the tolerancing, GD&T, and so forth. But it does even include things like welds and so forth. It's pretty robust. We have the QIF plans area. And so you've heard a lot also this week about this concept of the bill of characteristics and characterization of a CAD model. This is what we're talking about. We're talking about QIF plans, is extracting some of the key features and characteristics that need to be measured or need some form of operation. Like I said, maybe it's a weld or something like that. Extracting that information and sort of being able to capture it in what you could think of as a sort of a tabular form of just the list of all your characteristics. And there's quite a bit of information that you can add at the plan level. So we'll start off with just that idea of the bill of characteristics, simply a list of the things that need to be qualified, a list of all your characteristics. And then you can get deeper. You can get into, start refining that and start to create an inspection plan and identify how to measure things. Maybe you're assigning measurement resources. Maybe you're coming up with inspection frequencies for the parts that you're measuring. Maybe you're talking about statistical requirements that you need to meet for the parts coming off your production line. So you can start to refine it down to that level of sort of a control plan or inspection plan. And then finally, if you really want to get refined, you can even start to specify where you want to be taking sample points. So let's say that you decide that for a given surface, you want to be measuring with a CMM. You can define, these are the touch points where I want to be measuring this particular surface. So that's on the plans area. On the resources side. So resources is intended to capture measurement devices that may be used during a measurement, used for an inspection. And so generally speaking, the idea would be that you can define QIF resources that would correspond to, let's say, all the measurement devices that you have in your factory or in your entire enterprise. And then you can use those measurement resources when you're building a QIF plan. That's the general idea of what that's for. We have rules. Rules, the idea is to take templates or best practices that you might want to encode and encode those in QIF so that they can be applied towards your parts to try to create uniformity in the inspections that you're authoring. I'm going to give a little nod here to DMSC. So DMSC is not QIF. QIF is QIF, and DMSC is its own standard. But they're both managed by the DMSC. And there was actually an update that was done to DMSC, probably 7 or 8 years ago, I guess. That harmonized DMSC with UUID, with QIF in terms of the UUIDs that we have, being able to flow them down into DMSC. So it fits nicely within the QIF family, even though it's not formally a member of QIF. We have results. So obviously this is a very big one. You're able to capture data that you are measuring from real parts and associate that digitally with all of your MBD and your quality planning information. So this is how we can establish that digital thread all the way from the results all the way up to the product definition. And then finally, statistics is another really interesting area. The point is statistics works together with results to be able to carry out statistical process control and so forth. Okay, so those are the key areas there for QIF. I'll start getting into a little bit about the actual structure of how QIF has been implemented. So let me start with what I'm very informally calling the QIF core here. So this is kind of a couple slides here explaining some of the real foundations of how QIF works, QIF instance files work. So first, we have this notion of what we call a QIF document. This is our top level node. This is our top level element for QIF. And what we're talking about here is that an instance file, when you have a QIF file sitting on your computer, there's a QIF document at the top level. And that's a QIF document, and it can contain some of these things here. In this would be an example of some of the top-level elements that could be contained inside of QIF documents, some header information about datums, some information about some measurement resources. Like I said, maybe that's some CMMs and some calipers or something. The product, we'll get into that later, but that's the MBD. Features and characteristics, and then we have some results. So this would be an example of what a single QIF document might contain. But what's important is that almost all of these elements here, or very many of them, are actually optional. So when you're looking at a QIF file, and we'll get into this a little bit more, but when you're looking at a QIF file, there's lots of different types of data that could be inside of it. And so again, a little bit more about features, just to explain this. A feature. Here I'm defining an abstraction for referencing a portion of the part. Again, you can go on forever about what is a feature, but in general, that's what we're talking about. We're trying to refer to a certain region of the part that's under some type of a control. And so to talk about the MBD case, really it's a container. It's a container for referencing one or more geometrical entities on the part, usually surfaces. And so to look at this example, it might be kind of hard to see here, but this cylinder here, maybe this is referenced by a size and a position tolerance. This cylinder is made up of two half-cylinder surfaces in the CAD. That's just an artifact of how it was designed. At the end of the day, there are not two half-cylinders on the part that you're making. You're making a whole. And so that's what's important. What we're talking about is abstracting away some of the artifacts of how it might be modeled in CAD or how it might be represented in CAD. Because what we're talking about is a whole that needs to be controlled with the size and a position. So that's what we're talking about with feature, is sort of abstracting away the details of the specific way that the product or that the CAD is defined, and being able to speak in more abstract terms that are more relevant. So types of features you might see, like a cylinder, that would be a hole or maybe a pin. Plane, cone, opposite parallel planes, like maybe a slot cut through a part. Freeform, freeform features, obviously, just sort of freeform surfaces. And then there are all kinds of 2D features as well, circles, lines, ellipse. You have compound features, pattern features, maybe sort of what you might call a complex hole with a counterbore and a depth and a size and things like that. So we have all kinds of features to be able to capture all these types of entities. And then characteristics. Again, this is a control that's placed on a feature. Maybe a size or form or orientation or location, tolerance control, dimensional control, surface finish, welds, whatever. And how are they connected? So again, characteristics don't point to the CAD directly. Characteristics will point to a feature, and then the feature is what points to the specific product definition, to the CAD, which is an important abstraction. And with MBD, with QIF MBD, we have, so like in this image, we have an annotation, a 3D annotation that you can see with your eyes. That's rendered on the screen in a certain position, maybe in a certain presentation state. And that's actually part of QIF MBD, part of the product. But really, that's intended for human consumption. Strictly speaking, you don't need 3D annotations in order to have characteristics on your part. The characteristic is sort of the semantic, machine-readable description of what that control would be, and then separately you'd have the presentation element, which is meant for the human consumption. Okay, so I just wanted to come back to this. I mean, this really, I think it's a really key aspect of QIF that I just kind of wanted to reinforce, the idea of features and characteristics. Okay, so from here we'll get into some more details. And I do want to reinforce one thing. When is this? Yeah, I do want to reinforce one thing here, which is that we're really getting into some details here about QIF. Okay, so it's important to know if you're launching QIF across your whole company, nobody needs to know any of this. All right, these are the details. These are the details of QIF. That is really, for nerds. And I know you all are a bunch of nerds, so I'll explain it. But this is not necessary to know. It's, QIF is designed precisely to make it simple for the end user, that they don't need to worry about this stuff. You have a clean software implementation of this type of stuff, and it just works. I mean, generally speaking, this is more for software, software engineers that are getting into implementing QIF. This is where you really want to know this stuff. But for a lot of you, maybe your end users, you're thinking about how you're going to, the enterprise architecture for how you're implementing QIF or something like that. Having this level of understanding could be helpful. So let's go ahead and dive into it. So I also had shown, earlier in the QIF document side that a couple of the elements are the datums and the DRFs. These are important elements. I mean, basically, if we look at this example, okay, we have a hole over here. There's a size tolerance pointing to it. All right, here's our hole. There's the size tolerance pointing to that feature. But then we have a position tolerance. The position tolerance also references the hole, but with respect to A, which is sort of that bottom plane, and then B, which is that hole. So what does that mean? We have the position that also references the hole that we're controlling. And then we have the datum structure. So that position tolerance will also reference the datum structure, which is, we'll have a datum reference frame entity called DRF AB, which is that. DRF AB will reference datum A and then datum B, and then the datums reference these features. So not the geometry directly, they reference the features. This feature here and that feature on the bottom of the plane. So that's, actually it's pretty basic when you look at it. It's pretty simple, pretty clean understanding of how datums work with geometric tolerancing. The next major area is what's called the product. And so the product, generally speaking, especially in this audience, is the MBD. I mean, that's your CAD model and your PMI. There are other ways that you can store product data. It's actually possible to have a 2D drawing representation as your product. And obviously, in terms of current state, that's actually very common. And we have users that are very much doing this, doing QIF workflows with a drawing as their product. But the future state, sort of the state that we all want to get to, is using the MBD as the product. And so that's all of this. Our CAD model, the full CAD model, and the full description of the CAD model. All kinds of annotations, presentation states, so on and so forth. And this is how features and characteristics, like I was talking about, measurements, which I'll talk about later, which is the results. That's how this is attached to the model. Is that basically your features at the end of the day is that glue that exists between your underlying product, the product data, this product definition, and your characteristics. The feature is sort of the glue that sticks those things together. Plans. So what is QIF plans? So again, this is where we can look at the list of what are the characteristics on the model, and first of all just generate, like I said, maybe looking at it in a very tabular view, something like this. You hear about this term ballooning, which is an existing term. I mean, the term basically originates from you have a drawing, a paper drawing maybe, and you take a red pen and you start writing 1, 2, 3, 4 on all your annotations so that you can then transcribe that into a table, do your inspection, and you write your results into the table and so forth. So there's this term ballooning. And the idea is you have your drawing and you want to transcribe that into more of a tabular form of understanding exactly what there is to be measured. So this fits very, very well with the idea of MBD because now you don't have somebody, interpreting a drawing and reading the drawing and transcribing the drawing onto a table, but instead all of this is semantically described in the form of PMI, in the form of features, in the form of characteristics, and so you can very clearly understand exactly what needs to be measured. And so, like I said, I mean, that removes the idea of somebody having to manually do the work, but even more importantly, really, if you think about it, it means that when you have a QIF file, you get the same exact bill of characteristics every time because it's unambiguously described in the data format. It's not passing off a drawing to take a complex drawing, give it to 10 different engineers, and watch how you get 10 completely different quality plans coming back as the interpretation. That goes away. So it's a big deal. And by the way, that's why you hear so much at this conference. I've been hearing it a lot. I heard it a lot at 3DCIC last month. This idea of characterization of a model, extracting some of the, extracting basically this bill of characteristics out of digital product definition. So that's our bill of characteristics. That's what we're talking about when we're talking about QIF plans. And then, of course, like I said, you can get more refined from there, assigning, generating your complete control plan, measurement, resource assignments, and inspection frequencies, and all this kind of stuff. Yeah, and like I said, even assigning sample points that you want to capture. I want to make sure to capture so-and-so, points on this surface. So that's what we're talking about when we're talking about QIF plans. Results. So this is a huge one, and I think for a lot of companies this is kind of one of the big revolutionary aspects of QIF is you have your plans. So I mean we have this bill of characteristics. Maybe you just leave off this side and look at this. This was the work that we just did. And that was the bill of characteristics. So now we went off and we did some inspections, and hey, we have some results. I mean, it's it's pretty simple the way it works. And so we could just take these inspection results and attach them to the features and characteristics that we've already established. And since those features are attached to the MBD, we've established that entire chain of traceability. And so that's how we get the mapping between measurements that we're doing at the end of the line and our product definition that starts off right at the beginning. Statistics. So the idea of statistics is that basically you'll bundle together a set of results to be able to carry out statistics. And generally, the idea is that we've captured in these libraries is implementing classical statistical process control, which is sort of uniformly used in industry. And there are a couple different modes that it can be used. One is simply to specify a statistical method that should be used. So it's almost more of like, I guess you can think of it from a planning perspective, stating that this is the SPC approach that we're gonna use. These are the the CPK limits that we're looking for, and so forth. And then the other mode is to actually capture the results of an SPC analysis that has been carried out. So this is what we're talking about with statistics. It's bundled very much with the results side of the world. Resources. So here, this is a diagram from QIF3. That's kind of a taxonomy of a lot of the different measurement resources, measurement devices, and so forth that are characterized semantically within QIF. It's quite rich, and actually there's been some significant improvements in the QIF4 area in terms of growing that out and really supporting a wide range of different types of inspection technologies. Rules. So this is an interesting one to a lot of people. I think it's definitely pretty forward thinking. But yeah, the idea is, let's say you want to establish some best practices or templates or, corporate standards, however you want to think about it. But you don't just want to rely on the fact that, well, our quality engineers are really good, so we're just going to let them, decide what to do. Like, you want to have some uniformity. You want to have some uniformity in your measurement. Even if it is true that your quality inspectors are really good, you still want to have some uniformity. And so the general way that it works is just, it's an if-then statement. If some Boolean condition, then some action, or there's some decision or some rule that should be implemented. And so the Boolean conditions that can be checked, actually this is, it's almost infinitely flexible as far as the Boolean conditions that can be checked. But the simple ones is you could check for a tolerance type. Is this a profile tolerance, or is it a position tolerance, or is it a size tolerance, things like that. The feature type, is it a cylinder or is it a plane? The size of it, is the cylinder larger than 20 millimeters or smaller than 20 millimeter diameter? Is the feature a datum? Is it an internal, external, sort of user-defined sampling categories that could be defined? But then you could form a logical expression that can pretty much capture anything. So like here, is the surface area greater than 150 units of area? There's that kind of thing that could be done. So it's pretty flexible in terms of the rules you could, or the Boolean conditions you could set up. And then the actions that could be taken. So basically, you can specify information about the sampling that you want to do if we're talking about a dimensional inspection, like a coordinate dimensional inspection. The sampling that you want to do. And maybe that's, I want to sample exactly this, but more common, it's something like, we need to take at least 27 inspection points, stuff like that. You can specify fitting algorithms that will be used also for the purpose of coordinate metrology. And at a higher level, you can specify measurement equipment. And so that might be something like, if so-and-so use a CMM, or you could specify maybe a couple different types of devices that could be used, or you could specify orders of preference, or you could specify things that are not allowed. If this, do not use calipers, stuff like that. So that's rules. Like I said, I think it's a very, very interesting one for a lot of companies that are trying to sort of think about their future and what they're doing. So those are the main areas of QIF. Here's a little bit kind of describing how these relate to each other. So again, a single instance file might contain any number of these. So we have product, the things that we just went over, product, plans, results, statistics, resources, rules. A single instance file can contain, any of these. And it might have more than one. You might have a part or an instance file that only has product information, or you might have an instance file that only has rules information, or you might have an instance file that has all of these. I think lots of times people will look at a QIF file and say, well, what is this? Is this a rules QIF file, or is it a product data QIF file? It could be both. It's not quite that simple. QIF was designed with this in mind, because the idea is you might have maybe a file that has some product and some plans information, and it references some certain resources. That's done by design, that instance files can reference each other, so that you can have what's sort of a federated data model. And so that's just kind of driving this home. This is more. You can think of this as kind of a workflow direction. This is not really the way that files would reference each other, but these could be independent instance files that all contain their own data that sort of flow in this direction. That you have an MBD with some plans that were created from the MBD and resources and rules, and then from there we have some statistics done on a whole big batch of results, and those are all a bunch of separate files. But they, because of the use of identifiers, they're able to reference each other correctly and stay in a common state. Which brings us to the idea of, so how does QIF sit at the enterprise level? I mean, we're not implementing QIF in a vacuum. I mean, at the end of the day, your product definition is a native CAD model, which is being housed in a major PLM system, and that's where you're running your change control. So how does QIF fit into that picture? And the answer is it was designed to fit in very well with that picture. So generally speaking, you have your PLM software. We have our native CAD model, our Rev 1 of whatever your native CAD of choice is. So we'll generate this QIF derivative. This will be sort of a mirror of that native CAD model. Yeah, it's just another derivative CAD format. And then from there, outside of PLM, you could spawn whatever kind of data you want. And that references back towards that MBD model, which is a locked mirror of your change-controlled native CAD. And so it kind of gives you a snapshot in time, controlled by your PLM system, which is what you want, by which to start to generate some, let's say, plans and then measurement results data. This can continue on. You continue revving that model. You generate other QIFs. You generate other child data from there and whatever location throughout your enterprise. You go all the way on through Rev N. Yeah, usually, you want to make sure. I think Ben Urich was talking a lot about this. Making sure that models are validated and so forth.
Hey Daniel, wouldn't on your first MBD derivative, that's when you put your UUIDs in there?
Yeah, that's right. I mean, so that's when we're talking about, you might look at this, like you're saying, and you might think that, okay, we go from Rev 1 to Rev 2, Rev 3, but what if from Rev 1 to Rev N, there were only changes made in this tiny little portion of the part, but we had this entire other section of the part that stayed, the same. And we have all this inspection data, and we want to be able to look at the common inspection data from Rev 1 to Rev N that hasn't changed and be able to correlate it and do studies. That is possible with QIF because of what you're saying. I mean, so the use of the UUID system that we have allows you to track common entities across all the different revisions so that you can know between revisions what's changed and what's not changed. So that's the simple idea of understanding things at the characteristic level. Thinking about things from the characteristic level, that's kind of the benefit that it brought us. And so, yeah, we are talking about, with the addition of QIF into the PLM picture, I mean, we're talking about a very high data resolution. So instead of just talking about, well, I have this part number, we're talking about, well, we have this tolerance, this characteristic position 01 on that part number. And actually, once we get to results, we even say, yeah, and then I have some inspection results from, part serial number 123, with these specific inspection results. So it's adding, quite a bit of data granularity to what you're managing from your PLM system. Yeah, and then, I mean, I guess, maybe kind of a pitch here. Just the idea that, your metrology department is gathering a ton of data on the products that you're actually creating that are coming off your production line, and largely that's pass fail, and then that data is thrown away, which is crazy. And so that's the vision of QIF, is being able to capture that data, keep it in an organized manner, so that you could start to capitalize on that data. You could exploit that data for some value rather than just a pass fail decision, and then throwing it away. So, in summary, I'll wrap up and we have a couple minutes questions. I just wanted to bring this up again. Third time I repeat it, maybe everyone will remember it. Yeah, features and characteristics. I mean, this is really what it's about. And so, yeah, I mean, my call to action would be, if you're not a member of the DMSC, talk with Mark Thomas and join. We'd love to have you, and yeah, I mean, we need more participants here and growing out the QIF standard and seeing how it can transform industry. And So yeah, that's all I had. I think from here we'd open it up for questions. Yes.
Hang on. CT scan measurement technique, we use it for reverse engineering, and I'm not too familiar with, do they comply to QIF, like volume graphics? Are they involved, or just curious?
Yeah, so yes, so in general, CT applications, when it comes to inspection, definitely fit within the QIF space. I mean, so whether we're talking about, you could do dimensional inspections with CT, that definitely fits. And then there's also sort of, looking for defects, inclusions in the part and stuff like that. And that fits within the QIF workflow as well. In terms of, the software companies that are out there in the CT space, I know a lot of them definitely are in the QIF space. They're supporting QIF, from the perspective of importing MBD, importing your 3D PMI. If we're talking about doing a dimensional inspection with CT, then you would want that PMI. It's nice to have it. And so a lot of them can import that data. And then the other question would be on the export side. Once the analysis has been done, can the results be exported in QIF results format? And yeah, the answer is that a lot of them have. So it would just depend on the specific software you're using. Yeah.
We have a bunch of questions, so.
That's kind of a loaded question, and I kind of have my own answer, but I'd like to see your interpretation. The biggest confusion that I've seen with QIF in the customer base, not the vendor base, is that the concept of having multiple QIF files that can support your whole process. So you have a QIF model, you have a plan, you have results, and I get the common question, do I want a QIF file that contains all of that information in one? Do I have, where do I store them if they are multiple files? So do I have the MBD and the resources in, a network area that I can access, and then I drop QIF result files to another location? When do I sync them? How do I make them interact? And in my mind, you have different disciplines within an organization that are creating each of those entities. So you have design group creating MBD, you have probably quality area that's creating your plans and resources and whatnot, and then you have your CNN lab or whatever that's creating results. And I just like to, I think we need scenarios for when they're combined, when they're separated, why it's a good idea to separate them, and who's responsible for creating them. Just your interpretation of that.
Yeah.
I know it's a confusing matter when somebody just starts getting me QIF. Why do I have all these different files, and where should I put them?
Yeah, it's true. And I mean, so the good news about QIF is that it provides you with lots of data, but that's maybe also the bad news. I mean, you need to have a plan. If you're going to try to, wrangle this amount of data and really leverage QIF to the fullest, not just, I'm only going to use the MBD side or something like that, really use everything, you're going to be generating, like you say, a lot of data in a lot of different domains. And so you will need to have a plan for what to do with it. It's not just, I'll save it here and then I'll save the file name with a certain convention or something. That type of stuff, you're right, it's not going to cut it. And so, especially with the large organizations, that's why a lot of the enterprise architects, I think, really need to get into thinking, what will be some of the flows of data in their environments. At the end of the day, what software tools are they going to choose to implement this? Because again, QIF itself doesn't do anything. It's these software tools are going to flow data to each other, and they'll all work in different ways and kind of operate in different ways. And so those are decisions that need to be made. So I think it's a good point. And actually, one of the things that we were talking about as one of the plans for the DMSC, as far as QIF kind of next steps, especially after the release of QIF 4, is starting to think about talking about these scenarios that you're talking about, and coming up with sort of best practices for, if there's a workflow that, that does this, this, and this, and sort of defines some user story, then the best way that this can happen would be with, with this type, very specific technical details of how it should work. Especially more for the benefit of software vendors, so that software vendors can understand, like, what are the best practices of how to manage, large bundles of data. Yeah, so it's a good question.
Yeah. Is there anybody putting any thought into, or maybe the resource section of it, where you would capture calibration data for the various tools that you're listing in there? Is there already something set for that, or some value in that?
Yeah, there's quite a richness of data there in terms of calibration, in terms of performance test data for the devices. I don't know, Ed, do you want to comment any more on that, or? He's the guilty party here.
When you're building parts with particular calibration stamp on something, so it seems like having that living in some sort of a time reference would be kind of cool.
Yeah.
I'm not sure.
Yeah, so,
Thank you. So there's been effort to be sure that information surrounding the calibration status of an instrument and the particular maybe E89 or ISO standard that was used in the calibration is attached to those resources, or may be attached to those resources. And we've also been working on a separate effort that relates to the digital calibration certificates. So this is an effort that was started in Germany at PTB, and we have a parallel effort to utilize the data that's native to QIF to support that.
Thank you.
Are there any discussions with the PLMs about having standard ways to import QIF data into, and it's not just PLMs, maybe also ERPs and so forth, to be able to import QIF and recognize, okay, this is one that has some requirements, so it needs to go to RecIF, or this needs to go into SysML. Is there anything along those lines? Because I work for SAE International, so we are looking at QIF to potentially use as a digital format for our standards, and we want to integrate those in with the PLMs, and that would, if there were standard integrations, that would just be a lot easier.
Yeah. So, not that I'm aware of. As far as I'm aware, if we're talking about PLM or ERP or something, they would view it as just a business object. However, in terms of implementations of definitely PLM that I've seen, there are some companies that will configure their PLM to treat a QIF file as a specific type of business object that would be subject to certain types of operations and workflows and things like that within the PLM system. And so I think that's kind of where people are taking advantage of things, is sort of QIF automation within the PLM system. That's pretty common. That we're seeing quite a bit. Yeah.
So I think we have time for one more. Sorry, I know there's lots of hands going up everywhere.
So I'm going to go to the basics, like, so we are trying to add a lot of information around the CAD file. So does it increase the CAD size or the loading time with the CAD, because that's where the users are going to get back to?
No. So actually, the QIF file itself is pretty. It's comparable to a native CAD, like in terms of its size and loading time and stuff like that. So from a performance point of view, talking specifically about the MBD, it's been something that hasn't been an issue for, like, basically, especially an average computer that's running a CAD system, let's say. So for that perspective, it's pretty good. Yeah. Okay.
I think we could probably have questions for the next hour,
Yeah.
but
Well, thank you.
we have someone else that wants to talk. So thank you.